Nuestro ponente magistral en este Festival de Software Libre, este, nuestro querido amigo John Maddog Hall, en su portada aparece un breve fragmento de su trayectoria. Su trayectoria es mucho más amplia en el mundo del software libre. Además de amigo del Festival de Software Libre, amigo de México, es una de las personas con más amplia trayectoria en el mundo de Linux y del software libre. Y tengo el placer de presentarlo. Un aplauso, por favor.
Thank you very much. My talk today is about next year and its importance to computers. Because next year is the anniversary of a lot of things that happened in the last 50 years with computers. First of all, I will give you a warning that I'm going to try and condense 50 years of history into a 50-minute talk with translation. And my memory is not what it used to be. So sometimes I forget things, sometimes I twist things a little, but just like Donald Trump, it's sometimes the truth. Now, I admit to being really old. I am over 68 years old. I've had 2 heart attacks. And when I started to learn about computers, I was actually an electrical engineer. And in my university, there was no computer science degree. If people wanted to work with computers, it's because they needed the computers to do their work. They did not write software for other people. Now, because of that, I've actually been using open source since 1969. People were not creating binary-only software back then because there weren't enough computers of any one type to make it worthwhile. There were no PC stores. You couldn't go down to the corner and buy your PC, because if you did, you would need an 18-wheel tractor-trailer truck to take it home. You would need 3-phase electrical power to plug it in, and a 20-ton air conditioner to cool it. I've been coming to Latin America since 1994, and unlike a lot of Americans who think of Latin America as this fuzzy thing somehow south of Florida, I've seen the big cities you have, I've seen the universities you have, and I've experienced the people. I've had a lot of jobs in a lot of different companies, big and small, profit and nonprofit. And if there's one thing I pride myself on, is the fact that I'm not religious about things. I do what I have to do to get the job done. And sometimes that requires proprietary software. But I use it as little as possible because I believe in open source. So I'm going to take you back in time to when computers were physically very large. They might fill this room with hardware, but yet they were logically very small. Memories were measured in thousands of bytes. Disks were measured in megabytes, not gigabytes, terabytes, petabytes. Programs were actually run one at a time, even on a mainframe computer. And often, those computers did not have an operating system. The device drivers for those programs were linked into the program itself. And when you started to run the program, you actually booted the program like you would boot an operating system. For those of you who have worked with Arduinos, you'll understand. And if there was an operating system, it was very small and simple and specialized. So you would have an operating system for batch jobs, an operating system for time sharing, an operating system for real time. Now there was a rumor, and it continues to be a rumor, that companies back in those days created these operating systems different from each other to lock in their customers, to make sure their customers did not go to a different company. Well, I was there with those discussions, and they never happened. What our engineers talked about was how to make an operating system that helped our customers do their work, that helped their customers take the greatest advantage of these multi-million-dollar pieces of hardware that could only run one program at a time. Now, Digital had a computer system called the PDP-11. It was very famous for its time. And we had 11 different operating systems for it. An operating system for real time, an operating system for time sharing, an operating system for education, an operating system for health. If we had wanted to lock in our customers, we only would have needed one operating system. And that's why you can understand that this was completely false. So in 1969, about 50 years ago, there was a lot of amazing things that happened. For the first time, humans walked on the moon, and the entire planet came to a halt, watching TV to see these people walk out of the space capsule and plant their feet on the moon. Woodstock, a big music festival, happened, and people like Jimi Hendrix and a lot of others got their start in the music industry because of that. In New York City, in a place called the Stonewall Inn, the LGBTQ movement started because the police were beating up on gay people for the last time. And the gay people started to riot and started the LGBTQ movement. 50 years ago, the ARPANET started, which is the beginnings of the internet. And we only had a 15-bit address space because after all, there would only be a small number of computers talking to each other over this thing that eventually became the internet. Also, little noticed, in Helsinki, Finland, a baby was born named Linus Torvalds, and of course we'll hear more about him later. I wrote my first program in 1969, and it was the last time I shaved my beard. And in Bell Labs in New Jersey, two people, Ken Thompson and Dennis Ritchie, decided to write a new little operating system called Unix, just for fun. It was a research project. They didn't have to do it, but they wanted to do it. And so they started to write this little program. Now, as I said, back in those days, most software was distributed in source code form. There weren't that many computers. There was no Intel chipset. There was no PCs. In fact, probably the smallest computer you would buy would be about $50,000 US. And that's when $50,000 was a lot of money. There were also few professional programmers. You wrote the program to do your job. And I remember I had a professor who said to me, "John, You will never be able to earn a living as a professional programmer. And 50 years later, I'm still trying to find out if he was right. I don't know, maybe a couple more years. I might, I'd go bankrupt, I don't know. But there was no software copyrights or patents in programs back in those days. You could not copyright a program. You could not patent a piece of code. And so the way that you protected your intellectual property was to have a contract with somebody. And when you bought that piece of software, whether it's a copy of a compiler, you might have to pay $100,000 for that compiler. Now I want to put this in perspective, because in 1969, my parents bought a brand new house. The house was all brick on the outside, 3 nice-sized bedrooms, 2 bathrooms, a family room, a living room, a kitchen, a full basement, a porch on the back, a mother-in-law apartment for my grandmother, and a quarter acre of land for $32,000 US. And so one copy of a compiler could cost you the equivalent of 3 houses. You say, why would somebody pay that much money for this compiler? Because if that compiler compiled your code and made it run only 10% faster, 10% of the $2.5 million which you paid for that computer was $250,000. And so by spending $100,000, you in effect got $250,000 back because your programs ran faster. And you would negotiate for months on this contract. You'd have all sorts of lawyers going back and forth, and eventually you'd sign the contract, you'd pay your money, and maybe a week later, this person would show up with a magnetic tape in their hand. That was the engineer from the company, and they would load the source code for that compiler onto your system, go through a series of steps to get it to compile, run a series of test suites to prove that it was working correctly, and then they would go back to their company. But you kept the tape because you paid $100,000 for it, and you were not going to let them take it back. Not if you were like my company, Aetna Life and Casualty, the largest multi-line insurance company in the world, the largest commercial user of IBM equipment in the world. We had a 3-acre computer center and 500,000 magnetic tapes in our tape library on site, with another 100,000 in a salt mine in Idaho. We had 4,000 programmers, and we automatically ordered 2 of everything that IBM announced. It didn't make any difference what it was, a mainframe, a disk drive. We ordered 2. No salesperson had to call us and say, do you want this? No. You announce it, we buy it. It was a very interesting place for a young man to work right out of university. But in addition to all of this, there was a lot of people sharing this thing called software. We didn't call it open source, we didn't call it closed source, it was simply software. And we would give it to libraries for companies like Digital Equipment Corporation, DECUS, IBM, Share, Novell, Brainstorm, or we would upload it to bulletin boards so that other people could pull it down. We would give it to user groups because we wrote the software for our own use. And after that, if If anybody else wanted to use it, that was great. Now, as I said, in 1969, Ken Thompson and Dennis Ritchie were making this little operating system called Unix. And what was different about it was that they wanted to have a very small part of the system called the kernel. And the kernel was going to have a very small amount of functionality. And most of the functionality was going to be outside of the kernel in libraries and things like that. They did that because it was easier to get it right. And because they were writing this kernel in assembly language. They were trying to put it on a PDP-7 computer, which is an old computer with a very small memory. So small it wouldn't even run the assembler for it. And so they actually assembled the program on a different computer, punched out a paper tape, took it to the PDP-7, and tested it out. After they'd done this several times, they got a PDP-11 so that they could build a bigger system. And so they had to rewrite the entire kernel once again in assembly language and put it on the PDP-11 because the two machine languages were different from the PDP-7 to the PDP-11. So about this time, Dennis Ritchie said, that's enough. I'm going to write a portable language that we can write the kernel in that language, and then we'll not have to write the kernel again. And so he invented the language C. Once again, they rewrote the kernel in C, put it on the PDP-11, and everything was fine. Until somebody wanted Unix, wanted Interdata 832. And then that's when they realized that it wasn't just the machine instructions that were different, but the architecture of the computer was also different. And now they had to rewrite it again. But this time, they started to realize that there were parts of the kernel that were always the same. Scheduling a task, managing memory at the upper levels, managing your I/O and buffers at an upper level. And so they started to separate the two parts of the kernel, the parts that were independent of the machine architecture from the parts that were dependent. And the more they wrote this little system to go to different computers, the better they got at separating those tasks. Now everybody thinks that Unix was free, but Unix was never free. It was under license from AT&T. And Ken Thompson would take around his favorite tape to universities where he was doing studies and mentorships and things like that. And these universities would look at the code and see how it was written. And one university in particular, University of California, Berkeley, decided to start helping Ken and Dennis to write this thing called Unix. But they went off in one direction with AT&T going off in the other. Now to give you an idea as to how little Unix was actually free, if you were not a research university like Columbia or MIT or Stanford, if you were just a small two-year technical college like the one I taught at, you had to buy a commercial license for Unix. And that was $160,000 US per CPU. And you had to call up AT&T and tell them what your serial number of your computer was. How many of you know the serial number of your laptop computer? Slackers. And if that computer broke and you wanted to simply move it to another computer to still have access to it, first you had to call up AT&T and tell them the serial number of the new computer. And sometimes it was hard to find that person inside of AT&T. Other interesting things about those early days of Unix was they created this command interpreter called the shell that was outside of the kernel of the computer. It was something that anybody could simply replace their shell with another shell. And so if you needed some specific functionality for your job, you didn't have to have a completely different operating system. You just wrote a different shell. And it allowed your system to do something different. Another innovation was something called pipes and filters. This was started by a person by the name of Doug McElroy, who worked at Bell Labs. And it was so innovative for that time that Ken Thompson and Dennis Ritchie could not even understand the concept. And Doug had to write some of the first Unix commands to show how the output of one would go into the input of the next, and the output of that would go into the input of the next. We use this today. We don't think too much about it. It's kind of natural, flowing off the tips of your fingers. But in those days, it was revolutionary. Another revolutionary thing was a portable networked file system called NFS that came from Sun Microsystems. And the next Windows system that was client and server. You could actually run your application on another machine and over the network display it on some other machine. And these are just some of the innovations that came out of the Unix file space. But in 1992, Sun Microsystems had come up with this little single board computer developed at Stanford University, and they wanted to sell this as a workstation. But you only have to pay $30,000 for the workstation, and you paid $130,000 for the software. So they realized that that was not a winning model. And they went to AT&T and they said, if we only distribute this in binary form, would you lower the license price? And more importantly, not make us have to tell you the serial number? And AT&T said, sure. And they reduced the price from $100,000 down to $350, which still, to us, sounds like a lot of money. But remember, you're paying $15,000 to $20,000 for your workstation. And so $350 is not that much. Now, other companies followed this: Digital Equipment Corporation, IBM, Hewlett-Packard, and they all tried to reduce the price of the license to something that was acceptable. But the interesting part was that most of these companies did not go with System 5, did not go with the operating system that Ken Thompson and Dennis Ritchie had written. Instead, they went with the Berkeley software distribution from the University of California, Berkeley. Now, why did they do that? That's because System 5, even after all these years, from 1969 to this time period, 1992, did not have demand page virtual memory. It was a swapping type of system, which meant that your application had to fit entirely in the physical memory of your computer. And this was not very efficient. System 5 only had 2 compilers, the C language and Fortran 77, whereas Berkeley had 3. They included Pascal. BSD was a demand page virtual system that basically could have programs of almost unimaginable size for the time. 4 billion bytes. But most importantly, what System 5 had for its networking is something known as UUCP, Unix to Unix copy, a store and forward method of sending your email or copying your files, which would take a long time. Each computer would dial up the next computer in the chain, transfer the file, hang the phone up, then call up the next one in the line, and so forth and so on, until the file got to where it was going. And BSD had TCP/IP. And so most people went with BSD. The only problem with this was that AT&T had millions of dollars of advertising money, and Berkeley had virtually none. And so even though the people chose the BSD system, AT&T for the next several years kept pushing System 5 in magazines. Now there was one person who didn't like this very much. His name was Richard Stallman. He was a student at MIT, and he liked getting the source code for operating systems. He liked seeing how they worked. It made it easy for him, or at least easier for him, to have new hardware supported. And so he decided to start a project which he called GNU, which stands for GNU is not Unix, and create a complete operating system with all of the source code available. And in 1985, he created the Free Software Foundation to continue that. Now, Richard did something very smart. If he had started to write the kernel of the operating system back in those days, there would have been no code to run on it. And by the time he had all of the compilers and libraries and everything written, his kernel would have been hopelessly obsolete. So instead, he decided to write portable programs that ran on the top of other operating systems. And he started with a text editor called Emacs. A lot of people say he could have stopped at that point because Emacs is like an entire operating system. It schedules its own memory, it schedules its own tasks. It's huge. But people really liked Emacs, and they really liked the fact that they could do the same commands and manipulate their source code files across all these different systems. The next thing he did was a compiler suite for C and Fortran and other compilers that would compile code for different architectures on different operating systems and allowed programmers to use the same syntax and the same semantics across all these different systems. And what this did was not only make it easier for the programmers, but it also made it so that the code was more dependable because there were fewer of if-defs in the middle of the code, which took care of all the differences in the different compilers that came from Hewlett-Packard and IBM and all these others. By eliminating those if-defs, you were able to make your code easier to test and easier to write and maintain. And so large companies like Boeing actually turned away more efficient compilers to use this one that came from the Free Software Foundation. Now this is another important part because you remember that I told you the big function of these companies was to make their computers really efficient. But at this point, the price for the hardware had come down so much that now what was the most important thing was not conserving the computer, but conserving the human. To make sure you didn't have to retrain your human as they went from system to system. To make sure that the programs worked across all these different systems. Because human beings were now more valuable than the computers. And this is one of the big things that happens in modern day things. We're making computers to save human beings time instead of making the humans make their code more efficient for the computers. Stallman went on to create a whole series of utilities, and he kept building more and more things into his operating system. And this also allowed small companies to start up and to support some of this code. Companies would distribute the code on CDs and distribute it on, later on in DVDs. There were support companies like Cygnus that did work for companies like Boeing to support these compilers on different operating systems and architectures. Now, I went to work for Digital Equipment Corporation in 1983. And I'll admit that once again that I'm old. At that time, Digital was supporting Unix on PDP-11s and a system called a VAX. The PDP-11 had an address space of 64 kilobytes, and the VAX had a virtual address space of 4 gigabytes. We brought out several different systems based on BSD Unix, starting in 1984, and then continued on. Now, because all these vendors were fighting with each other, trying to bring out the best Unix system, they created what we called the Unix Wars. Sun Microsystems versus Digital, versus IBM, versus Hewlett-Packard. Most of it was in the scientific and technical space, which is about 16% of computing. And the rest of them were starting to creep out into the commercial space, where 84% of the computing was done. So 84% would be banks, people using computer systems for doing commercial work instead of scientific or technical. They divided up into two camps. One was called Unix Systems Labs, which consisted of Sun and A&T banding together. And that was when Sun decided to switch off of their Berkeley-based system called Sun OS and go to a System 5-based system called Solaris. Digital, Hewlett-Packard, IBM, and others formed an organization called the Open Software Foundation in 1988, and they took a different route. Instead of only using the code that came from AT&T or Berkeley, they created a standard set of application programming interfaces, APIs, and they published those along with a test suite. And if your operating system could pass that test suite, you had the right to call it Unix. They created a sample implementation based on the CMU mock program. And some people used that sample implementation and improved it to make their distribution, and others simply changed the system they had to meet the test suite. Eventually what happened was Unix Systems Labs sued a little company called BSDI because BSDI was using the Berkeley code and releasing both the sources and the binaries for $995 US. Now remember, the prices we talked about before, the $350, that was for a binary license. If you wanted to get the source code for Unix, you still had to pay the $160,000 for the source code license. And then you had to pay maybe another $35,000 for the actual code of the company you were looking for. So it's very expensive. And this little company selling, source code and everything for System 5 Unix for basically $1,000 was sued by AT&T. And that lawsuit dragged on for many years, being settled in 1994, when the University of California, Berkeley had rewritten every single file in their distribution to make sure it contained no more AT&T code. And they created this distribution called BSD Lite, which is the basis of FreeBSD, NetBSD, and OpenBSD today. Now in 1991, this university student in Helsinki, Finland, had gotten a brand new 386 computer for Christmas. And the operating system that came with it was only a swapping operating system. It did not use demand page virtual memory. And he knew he wanted to have that, and he knew that Unix would support it. Now, to be fair to Microsoft, who created that operating system, they not only had to support 386s, but they also had to support 286s and 186s, which did not do demand page virtual memory. And so they did not bring out a demand page virtual memory system of 64-bit until Vista, 11 or 12 years after this point. But this university student, who you know as Linus Torvalds, decided he was going to create an operating system just for fun to take advantage of his little 386 processor. Now, how could he do this at this time? What was special about this time? First of all, the 386 was new for Linus, but it was actually not in the mainstream at that point. 486s were coming out. Pentium systems were on the horizon. And a lot of people were taking their old 386 computers and replacing them with a 486 and saying, okay, what do I do with this old computer? Oh, I'll practice with Linux. I'll put Linux on it. And I'll use it as a DNS server, or I'll use it as a gateway, or I'll use it as a small server or a print server. So that was the first thing, that now you actually had computer systems that you didn't have to make the maximum out of it because you were going to throw them out otherwise. The second thing was that the internet was coming into the home. It was no longer something you only found in university and you only found at your company. You could bring it into your house, and so you could work on this little project from your house and made it nice. And there was a huge amount of information online about how to write operating systems. And there was examples like Minix that people could look at. And finally, the World Wide Web was maturing at this time and made communication and even porn much easier to do. So we go forward a little bit more. It's now 1994, 10 years after George Orwell's book of 1984. And all of the system vendors have basically given up the desktop to Microsoft. At that point, Microsoft had about 90% of the desktop. Apple had about 7% of the desktop, with some Unix systems and others taking up the other 3%. And companies like Digital Equipment Corporation and IBM had said, let Microsoft have the desktop. We'll do servers. But at that time, Windows NT was now starting to work its way into the server market, and so people were a little bit worried about this, that Microsoft was going to have everything. Tim O'Reilly, who had a company called O'Reilly Associates, was busy publishing Microsoft books because he had given up on the Unix books that had built his empire. And in order to save his people and save his company, he was now publishing books on how to program Microsoft products. And then they released version 1.0 of the Linux kernel. And all of a sudden, people started to build distributions, Slackware, Yggdrasil, soft landing systems, some of which don't exist anymore. But people started to realize that now they could have a nice little Unix system for free with all the source code available on their cheap, miserable, crappy Intel PCs. And this exploded because even though there weren't a lot of applications available for this, there was a lot of good stuff in there that you could utilize in your systems administration space or your home or things like that. You could set up an email server or web server, firewalls. In fact, we even called them LAMP, Linux, Apache, MySQL, and Perl or Python, whatever you want. And it allowed you to repurpose these old machines. And people could, started creating telecommunication centers and stuff. In 1994, another thing happened called the Beowulf systems. We'll get to that in a moment. And in 1998, the database companies started to port. And having brought out about 15 or 20 operating system architecture combinations in my lifetime, I realized that Linux was following the same path that all of these different systems did. And I knew that Linux was going to be something special. It was going to have commercial value. In the year 2000, embedded systems started using Linux. Because before that point, companies would write their own little operating system and their own little compilers for Intel or maybe one other chip. But two things happened in the year 2000. A lot of other chips and architectures came out. ARM, PowerPC, MIPS. And people wanted embedded systems to use these chips. That was a lot of work to support all these different architectures. But the second thing was, people wanted their embedded systems to talk to the internet. And all of a sudden, you needed to have security. And you needed to have a TCP/IP stack. And all these other things that people had not put into their embedded systems. But they realized there was this one computer system called Linux that had all of these things and already ran on all of these architectures. And so in 1 year, Linux went from not being in any embedded systems to being the most used operating system in embedded system designs. Now in 1994, there was a problem. Supercomputer companies like Cray and ECL and CDC were going out of business because to create a supercomputer took a huge amount of money, a huge amount of engineering, and then you may only sell 5 or 6 of them because that's all the people could afford. And they had a very short lifetime because you were buying a supercomputer to have the world's fastest computer. Well, that lasted until the next fastest computer came out, and then you only had the second fastest computer, and that was no fun. So in 1994, NASA needed supercomputers for something called fluid dynamics. And if you're not familiar with fluid dynamics, basically it's everything. Fluid dynamics is used for forecasting the weather, for forecasting ocean currents, for describing what this water is doing in this bottle. Even glass is actually a supercooled liquid. And if you give it 1 million years, it ends up as a little puddle on the ground. That is fluid dynamics. And it's very important to NASA that they have computers that could do fluid dynamics quickly. And so 2 people, Dr. Thomas Sterling and Donald Becker to realize that you could break down this huge problem into thousands of little problems, or even millions of little problems, and then bring the answer together very quickly. And you could do this with these weak, miserable, crappy, commodity Intel PCs. And after you got finished with your main job, you could even break the thing up and sell it off to people, or add more units to keep it as the world's fastest computer. And then so Beowulf gave a new marketplace to this Linux system that sold thousands and thousands and thousands of computers. We've always been talking about the year of the Unix desktop or the Linux desktop, and it still has not happened. One reason why it took so long is because there was one standard for the desktop, and that was Microsoft. Microsoft owned 90% of the marketplace, and people like my father would open up a paper notebook and write down things like turn on system. Type this into your login name. Type this in for your password. And then step by step, tell what you had to push or shove to make the system work. But what happened was that browsers and cell phones broke that standard. People couldn't remember anymore this, push this button, because everything was changing. And so now people had to learn how the computers worked instead of just how to follow these steps on a piece of paper. A second problem happened was lack of games. And to me, I'm not a gamer. I don't play computer games. This is kind of a hard thing for me to swallow, but I know a lot of you do like to play games, and you want to have that one game on your system that's very important to you. And those games were not there. And why aren't they there? It's because gamer people, their companies, they write to the place that has the greatest number of desktops, and that's Windows. And the second greatest number of desktops was Apple. And there's another problem with gaming, and that's the fact that, in a desktop system in Brazil, 84% of the software was pirated. In Vietnam, it's 96%. In China, it used to be 92%, but now they're down to only 84%. If I was to guess, perhaps Mexico might pirate, be kind, 75% of your desktop software. But in the gaming space, you actually pirate 90%. And so here's a gaming company, and they write their game to Windows, and 90% of the Windows people pirate the software. That means they don't sell very many copies. But it gets worse when it's 90% of the 7% of Apple people. And it's truly worse when it's 90% of the 3% of Linux people. And it's especially bad because Linux people want everything for free. And so even if you pay for it, you want it for free. And that's why most gaming companies do not support Linux. And finally, there's a concept that everybody wants to have a word processor on their system. And maybe everybody wants to have some, other types of software. But at the end, there's that one last application that people may want in order to buy the system, and it's a different application for each person. And to build this application suite costs a huge amount of money. And so these are reasons why Linux and Unix is not on the desktop. But we have some good news. It's because a lot of people don't use the desktop anymore. They use their Android phone. They use their Apple phone. They use tablets running, basically with a browser in it, like Chrome. And so Linux is in 2 out of the 3 of those. It's the basis of Android. It's the basis of Chromebooks. And so we're actually winning in that. Another way of winning is use of something that's celebrating its 20th anniversary. It's called the Linux Terminal Server Program. And this took cheap or old computers, even 286s, and put a little bit of software on them so they could act as a window onto server systems and now cloud systems. And this type of software, that's free software, saved one particular company millions of US dollars, which is why they dedicated a programmer from their staff to help out with this project. Now another threat came along from Apple. Apple decided that computers were no longer for computer people. They wanted to make a customer-consumer product out of them. And they brought out the iPad, and they took FreeBSD and made that the basis of XOS and iOS. And they thought that they had it gold. But the problem is that Google and Android foiled their plan. Now again, we're going to go back in time a little bit to the beginning days where Bill Gates and Steve Jobs were friends. And Steve Jobs decided he's going to build the entire stack, hardware, software, and everything, and present that to the customer, and that's a very good business model. The problem with the model is that you can't make money with Apple unless you're Apple. And so the only people that advertise Apple is Apple. Now, on the other hand, Bill Gates and Microsoft said, if you can even say the word Windows, we'll allow you to put your software onto our machines. And so everybody that was not Apple supported Microsoft. And that's why Microsoft ended up with 90% of the desktop, and Apple only had 7%. I predict the same thing is going to happen with Apple and Android. And right now, we can see that Android is outselling Apple more than 3 times. And so in the future, I predict that Apple will own 7% of a very profitable market. They'll make money, lots of money. And Android and Google will own the other 90% with some things in between. Now we have the cloud. People are saying, oh, don't use the desktop anymore. Everything is in the cloud. Move everything to the cloud. Hide the operating system in the libraries from the customer and just lease that to people for the rest of eternity. And now we can see why this is so important. Because all of you people that are pirating your desktop software, now you're just going to be leasing it from these companies forever. And they'll charge you just a little bit of money, but it'll be a little bit of money forever. And if you don't pay it, you won't have access to the cloud. And that's the problem. And they give an illusion of privacy and security to the customer. And I'm sure you've all heard the story about how the FBI went to Tim Cook at Apple and said, create a back door to your phone because we need to capture these crooks. And Tim Cook said, no. That was great. I liked Tim for that. But the problem was that the FBI had not done the right thing. And if instead they had gone to a court and gotten a subpoena for that through the legal channels that they should have, they would have gone back to Apple and said to Tim Cook, open up your phone. And if Tim Cook said no, then Tim Cook would have gone to jail for contempt of court. So it's only a matter of time before the NSA and the CIA and the FBI go to the courts, get that piece of paper, that court order, and open up, and your data will be exposed. So we need to get the cloud back to the people. And this is especially important to people in Latin America because you are not US citizens. You cannot vote Trump out of office. You're leaving that up to people like me. And I can tell you, it's hard. So you have to protect yourselves. And so, I'm going to do a shameless advertisement here. I'm going to tell you about some cloud software that's created by my company, Optin, that is open source, free, peer-to-peer cloud software. It allows you to set up your own cloud. It allows your hosting providers here in Mexico to set up a cloud. It allows universities to set up a cloud. And they can both buy and sell cloud services amongst yourselves. Our company also creates a blockchain router. It's like a Wi-Fi router that you have in your house or your business. But it's also a NAS server, which helps to cut down on your internet traffic. It's an Internet of Things gateway so that you can make Internet of Things control units to control your house. But most importantly, in a lot of ways, it mines cryptocurrency at a very efficient rate. So the whole blockchain router only uses 18 watts of power. And that's less power than your general Linksys router uses. That doesn't mine cryptocurrency. Now, this original design came from Optin. We put it up on GitHub. It's an open design. And we're now taking it at the University of Sao Paulo and manufacturing it. And over the next several months, we're going to be moving that manufacturing information to countries like Mexico so that you can manufacture it too. Now, this company, Optin, was started and led by 3 open source people: Alex Karasutu, who is the CTO and founder; Sally Kudari, who's the director of marketing, but also is the director of marketing for the Apache Foundation. Alex has worked for the Apache Foundation doing lots of things. And Maddog. Now, in addition to all of that, we have a project called Caninos Lucos in Brazil that's making 3 hardware platforms. One is a tiny little hardware platform we call the Pulga, or Flea. It's a sensor computer. It runs off of batteries. The Labrador is like a better Raspberry Pi. And the Subutai blockchain router. This has become the basis for Brazil's Internet of Things initiative. And we are going to be creating solutions for agricultural industries, health, and smart cities. And we would like Mexico, as well as a series of other Latin American countries, to join in with this. Subutai and all of these systems will be using Debian as the main platform, which is a general open version of GNU Linux. And we want to spread this to other Latin American countries to help out. So in summary, Unix was the first system to have portable code and portable people. That you could have the same commands, the same programming interfaces that went across multiple pieces of hardware. And of course, GNU Linux followed that and clarified that. GNU Linux created collaborative design of multiple companies working together to reduce the costs by using open source and free software design. And we've extended that to free software and hardware and free culture. So this is my last shameless plug, or next to last. Next year, as I said, is a very important year. 20 years of the Linux Terminal Server Project and the Linux Professional Institute, of which I'm the board chair. 25 years of version 1.0 of Linux, the BEO of supercomputers, the Alpha Linux distribution, and most major distributions. 30 years of the World Wide Web and the Unix license plate that I've had on my car. And 50 years, a half century of all these other things. So help us celebrate this. Next July in 2019, there's going to be a DebConf in Curitiba, Brazil. And I would like you all to bring at least 2 Windows users to the next Fizzle event to show them how powerful our systems are. Thank you very much.
La Universidad de Guadalajara, a través del Centro Universitario de Ciencias Económico Administrativas y el Grupo Linux de Occidente, otorga el presente reconocimiento a John Maddog por su valiosa participación como ponente magistral, impartiendo la conferencia 50 años de todo lo que termina en X en el Festival de Software Libre Vallarta 2018. Por favor, un aplauso.
Y bien, es para mí un honor estar aquí al frente representando a toda la gente que hace posible este evento. Inicio agradeciendo, por supuesto, que a la Universidad de Guadalajara, al CUCEA principalmente, el Centro Universitario de Ciencias, Económico, Administrativas en Guadalajara, y a su rector, José Alberto Castellanos Gutiérrez, que apoya estas iniciativas y estos eventos desde hace 15 ediciones. A todo el staff que lo hace posible, aquí solo hay una pequeño grupo de ellos que ayudan desde hace semanas y algunos desde hace meses, involucrados de lleno en la organización de este evento, muchos de ellos de forma voluntaria. Nuestros amigos de CUCOSTA, los alumnos de las carreras que voluntariamente han participado y ayudado este año. Y bueno, al traductor, también un estudiante a quien hay que brindarle un aplauso por su trabajo. A Brandon, muchas gracias. Gracias, es un voluntario que viene de la licenciatura en Tecnologías de la Universidad de Guadalajara. Y por supuesto, mi más sincero reconocimiento a los ponentes que están aquí al frente y a los que no están también, lo que ellos representan y lo que han dejado para venir a transmitirnos con su conocimiento un poco de todo esto que hace de este evento un festival, un verdadero festival. Hay mucho que nos llevamos, muchas horas de aprendizaje y conocimiento, y que cada año muchos de ellos se dan cita para estar presentes en este Festival de Software Libre. Un merecido aplauso también para todos ellos, muchas gracias. Y por último, a la gente que nos acompaña, docentes, alumnos, trabajadores de gobierno, empresarios, emprendedores en general, que vienen de 15 estados de la República de Estados Unidos y Canadá. Aquí tengo algunos sitios que quiero mencionar, que vienen grupos de la Universidad de Guadalajara, Universidad Tecnológica del Norte de Aguascalientes, INEGI, Universidad Autónoma de Baja California Sur, Universidad Autónoma de Nayarit, Universidad Tecnológica de Rodeo, Tecnológico Superior de Santiago Papasquiaro, Instituto Tecnológico Superior de Jerez, Autónoma de Aguascalientes, Autónoma de Baja California Sur, CONALEP, Tecnológico de Morelia, Bosch, Cuauhtémoc, IMSS, Universidad de Bahía de Banderas, Universidad Autónoma de Chihuahua y muchos más que nos acompañan. Muchas gracias a todos y sin más yo los invito a que tomemos la clausura de forma de pie, por favor, si es posible, para dar por terminado este evento. Y bueno, muchas gracias. Siendo las 3:26 horas de la tarde de este sábado 3 de noviembre, declaramos formalmente clausurados los trabajos de este Festival de Software Libre 2018, sabiendo que se alcanzaron los objetivos planteados inicialmente de aprendizaje y de compartir conocimientos. Es un placer y un gusto que estén aquí y nos vemos en el próximo Festival de Software Libre Vallarta 2019, el 1, 2 y 3 de noviembre del próximo año. Muchas gracias a todos y buena suerte. ¿De qué?